Hello, everyone, and welcome. As usual, we'll just give it a couple of minutes while everyone filters in. So bear with us while, yeah, we reach some steady state of our participants. All right. I'll start my introductions because if you have been here before, then many of you will have heard some of it before, so we may as well get through them now. But yeah, welcome everyone, and thank you for joining the fifth of 9 lectures on this virtual PhD course on urban economics in developing countries. This course is hosted by the International Growth Centre in partnership with the Bureau for Research and Economic Analysis of Development. Now, the fifth of 9 means the fifth week, and that means two things. Firstly, we are over halfway, and you are still here, which is positive. So thank you very much. We've been impressed how many of you have turned up to learn each week, and the feedback we've received has been very much appreciated and wonderful. So we're glad to have contributed to this global learning. I think, as I said in my week 2, I think we have registrants from over 100 countries, so we're really managing to bring urban economics to a wide variety of nations and people. So we're very happy for that. And secondly, the fifth week means that we're going to be focusing on part 2 of our kind of connected city bundle module, let's say, specifically looking at service delivery with respect to water and sanitation, service delivery broadly and water and sanitation specifically. Before we get into that, let me reintroduce myself. My name's Oliver Harmon. I'm a senior policy economist at the International Growth Centre Cities that Work initiative. And that's the first time I've said that out loud because it was announced yesterday, my promotion. So I expect some digital applause if possible. No, I'm going to be chairing today's lecture. And to teach us something about this connected city, we are grateful to be joined by Kelsey Jack, Associate Professor in the Haas School of Business at UC Berkeley. Kelsey is also a fellow of BREAD and importantly organized the previous BREAD IGC PhD lecture series on environmental economics, which was almost as good as this one, but worth checking out either way. It's on both BREAD and IGC's website. We're also fortunate to be joined by Matt Turner, who's Professor of Economics at the Department of Economics at Brown University. Matt is also the past president of the Urban Economics Association, so knows this world very well. Speaking as an individual and as an institution, we admire Kelsey and Matt's work, and I think they themselves have learned a lot from developing country cities, and as a result has taught us a lot about developing country cities. So we're excited about hearing from them today. Okay, any people who haven't been here before, I have 2 more brief housekeeping rules before I get out of the way before the main event. The first is that this lecture is kind of broadly 1 hour, delivered in 2 halves by Matt and then Kelsey, after which we'll have time for kind of 20 to 30 minutes of Q&A after the lecture. If you would like to act as a live participant during the lecture, meaning you'll have access to the microphone and video and can interact verbally with Kelsey and Matt during the Q&A, please virtually raise your hand now, and Greg will our wonderful technical assistant, will select a few of you to join the discussion and indeed be those faces for Kelsey and Matt to speak to. And as an incentive for this, as last time, I will come to these live participants first for the Q&A. So if you want to get yourself to the front of the queue, please do. And for other participants, please, yes, type any questions you have throughout the lectures in the Q&A box at the bottom of your screens. You can submit questions at any point during the discussion. It would be great if you can include your name and affiliation if possible when you write them down. And also people who don't have questions can upvote the questions of others by clicking this thumbs up icon. And similarly, I will come to those most upvoted questions first. Okay. One final note is that yes, we are recording all the lectures in the series, and these will be available on IGC's website as long as with the slides and the reading lists from the lectures. And finally, since I know it is of importance to many people here, for those who attended at least 7 lectures of the series, you'll be issued with certificates on completion of this course. Okay, that is all from me. And without further ado, I'd like to hand over to Matt to lead off with the lecture.
Mute, and I need to share my screen, which we practiced just a minute ago. Oh, here we are. All right, that should be full screen and everybody should be able to hear me, yes?
Perfect.
Okay. So thanks for the opportunity to talk today. I'm going to talk about what we know about how water and sewer delivery, or water and sewer services, affect the way cities develop. And with that, let me get going. All right, so what you'll have learned in sort of the earlier lectures in this series, right, is that we're more productive when we work at higher densities and with different people than the people that we want to live with. All right. And the way we solve that problem is with cities, right? And cities are the way that we work with different people than we want to live with, and we work at really high densities. Right. So that right away gives us 3 questions, right? Which is how much more productive and why, right? And that is the sort of central topic of urban economics, which is why are there agglomeration economies, right? The second one is how do we organize this separation of work and residence, right? And that is sort of the central theoretical mechanism in almost all urban models, which is like, how does commuting affect the way cities are organized, right? But if you read this question, like there's this third thing lurking in there, which is what determines our willingness to tolerate density, right? And that is not something that we've paid very much attention to, right? And so that is the thing that I have been working on a bit, and that I want to talk to you about today, right? Because it may be that it is just as important. We know that being able to move workers back around the city, and in particular into and out of the city, out of the center, is really important for the structure of cities, right? Maybe it's not that hard to imagine that the ability to manage their sewage is also very important, right? And that's not a question that we have very much systematic evidence about, but we have a lot of suggestive evidence that it could be really important, right? So what I want to do today is describe what we know and and highlight the things that we don't know. Right. I think that substantially this talk is going to be a call for more research. Okay, so there's lots of policies, all these public health policies that I think affect our willingness to tolerate density, sort of casual empiricism, right? I made this list. I thought, I was thinking about, of all the services that my city provides, which ones could I live the longest without? And I figured I'd make it about 3 days without water. Law and order is like, I don't want people coming to my house and taking my stuff and beating me up. So I figured that's high on the list. I think after that is sewer service. All right. And then as I go down that list, it's vaccination, and then fire, trash, noise pollution in no particular order. Right. And the impact of these services, or these public goods, on how cities are organized, we just don't know very much about that, right? And sort of the exercise I would like you to do while you're listening, while we're looking at this list, is think about where you would put bus rapid transit on this list, all right, and where you would put schools on this list. And I think that bus rapid transit doesn't make this list at all. right? Roads would be down below vaccination. Schools would probably be right around vaccination. And so sort of casual empiricism tells me, suggests to me that all this stuff about water and sanitation and just things that we take for granted in the developed world are probably first order for the development of cities, particularly in the developing world. All right. So I'm going to focus on water and sewer, right? But that is all these other things are still out there to be studied, and I think we don't know much about those either. All right, so the structure of the talk is I'm going to show you some evidence of the importance of public health, sort of broadly defined, for the organization of cities. Right, I will show you some evidence for the importance of sewage and sanitation service for public health, right? So if you put those two things together, you get evidence for the importance of sewage and sanitation for the organization of services. There's a step in the middle, right? And then I will show you what little evidence we have, which makes that, which looks at that link, looks at that relationship directly, the relationship between water and sewer and how cities are organized. And then after that, I'm going to talk about suggestions for further research. Okay, so to start, what do we know about the availability of water and sewer? I think that the natural way to start is with some definitions, all right? And I try to think about things, treatments that affect large sets of cities, and so I went to rather than think about a particular experiment, I was thinking about data I could get for large sets of cities. So I went to the World Bank, right? And here's the World Bank's definition of what does it mean to have water, safely managed sewer? What does it mean to have safely managed water, right? And you can read these definitions. So safely managed water is drinking water from an improved water source that's located on the premise, available when needed, and free from fecal coliform and poison. Okay, and then as you go to the second one, the light blue, is the same thing, but you have to walk for it. And then after that, things start to get ugly, right? And then the right panel is the corresponding thing for sewage, right? And if you look, the top one is use of improved facilities that are not shared with other households, where excreta are safely disposed of in situ or transported off and treated off site. If you look down at the bottom, improved facilities includes flush or pour toilets, septic tanks, pit latrines, ventilated improved pit latrines, composting toilets or pit latrines and lids with slabs. So this is safely managed is actually not that high a bar. All right, and then when you get below that, then you're camping, right? So that's the sort of data that the World Bank collects, right? That's interesting because we can, with those definitions in hand, we can look at the data they've collected around these definitions, right? Here is the fancy graph that they made to describe the availability of sewers. All right, so this is people who have this is access of water and sewer service worldwide, not restricted to urban areas, right? So remember, dark green is good. You see sort of 40% of the world has access to safely managed sanitation, which was that low bar that I described on the last slide, right? And there's a lot of variance across places, okay? So, and in some places, there are substantial fractions of people who are basically camping, right? Water is much more widely available. The engineering problem of delivering piped water is easier than the engineering problem of collecting sewage, right? The reason for that is piped water travels in a pressurized closed system, and so it can go uphill, right? Sewage can only go downhill, and it has to work off of gravity, right? And so that means that organizing a sewage system is harder than organizing piped water, which is why there's less of it. The second reason is that a typical sewer system only works if you have piped water, right? So in order to have a flush toilet, you have to have piped water one way or the other. And so piped water sort of has to come first, right? And so you see piped water is less of a problem, okay? These the slides I just showed you, the World Bank data, are for the whole world. All right. They break this out by urban and non-urban. As of about 2018, 15% of the world's urban population, same World Bank data, and 40% of the world's urban population does not have access to safely managed water and safely managed sanitation. So 40% of the residents of the world's cities do not have safely managed sanitation, where safely managed sanitation can just mean a nice pit toilet, right? So just try to wrap your head around that. Okay, so public health and the organization of U.S. cities, right? So this is what I'm going to tell you is what I think of as the conventional wisdom for how urbanization happened in the U.S. All right, so this slide shows two graphs. One shows the percentage of employment in agriculture from the one on the left from 1800 to 2000. And you see that we went from about 85, the US went from about 70% employment in agriculture to 1.5% employment in agriculture over the 19th and 20th century. On the right shows the urban share, right? So these are both basically inverses of each other, and they both show the same thing, so that's good. Right. So this is the period when the U.S. became highly urbanized, right? Which was the late 18th, the late 19th and early 20th century. Okay. Over the same time, particularly in the 20th century, we saw GDP go up. This is that first thing that cities do for us, is they help us with productivity. All right. Here is some information about public health. So what do we have? We have urbanization is going up in the 19th and early 20th century. Incomes are going up very rapidly, right? The x-axis in this is years. It covers about the same time frame. It's 1800 to 1920 or 1900, right? And it is deaths. It's crude death rate for different cities. Boston top left, Philadelphia top right, New York bottom left, New Orleans bottom right. All right. What do you see? You see that right around 1860, 1870, the variance drops. Right? So right around 1860, 1870, people started doing modern health interventions, right? We got the germ theory of disease, started building sewers, started building municipal water supplies, and the variance dropped. So we started getting rid of all the cholera and typhoid epidemics that were killing people. And then the overall mortality rate starts to fall, okay? Right. So what this says is the way the timing of this lines up is that all of those we solved epidemics right around the time when urban population started to take off. Right. So if you were doing sort of a naive time series analysis on this, it looks like solving the problem of urban epidemics was necessary for U.S. cities to really start growing. Okay, here is more of the same. This is the infant mortality rate in the U.S. Look at the gray line is more interesting than the dash line. The dash line is Massachusetts. And what you see, this figure continues another 100 years from the ones I just showed you. What you see is not only does the variance fall, right? But the infant mortality rate falls like crazy. So the infant mortality rate in the U.S. in 1850 was 1 in 5. So 200 in 1,000, 1 in 5, and it is now 5 in 1,000, right? So clearly the public health revolution has happened hand in hand with the industrial revolution, the growth of cities, and the rise in incomes. Okay. Here's more, right? This shows the ratio of the crude death rate in cities and in rural areas, right? So between 1870 and 1880, for every person who died in the countryside, 1.38 people died in the city, right? Between 1880 and 1890, that ratio increased to 1.5, and then it started to fall, right? And by 1920, we were down to 1.2. Now it's at parity or even lower for cities. All right. Okay, so we have these three facts. Over the 19th and 20th century, urban population increased, productivity increased, urban mortality rates fell. The conventional wisdom around this is that the decline in absolute and in the absolute and relative level of urban mortality was an important contributor to the process of urbanization and growth in the US. Okay, here's more, right? These are graphs on the left showing rental rates. This is a rent gradient. So on the x-axis is distance to the center, log distance to the center, and on the y-axis is log of rent for a typical Zillow house, whatever Zillow thinks is the typical housing unit. The green line is pre-COVID, the red line is post-COVID, right? So what we see is that with COVID, right, the rent gradient flattened out, right? Which says that the effect of COVID on the way cities were organized in the US in the beginning of the 20th century was important enough to show up in rental data, right? The graph on the right is the same thing for house sales, and it's a little harder to see, but the housing price gradient flattened out in a year, right? So this is more evidence that public health stuff like the typhoid and cholera epidemics, but a 21st century epidemic, right, are reshaping cities. Okay. All right. So that's what we've got, right? So that's suggestive, right? But it's nowhere near the standard for an applied microseminar. All right. But that's kind of the state of that is what I think is the state of the art. If anybody knows research which can pin that down better, I'd love to see it. But that's kind of what the evidence is for this idea that public health is really important for urban development. Okay, the pattern in modern Africa, right, is not obviously the same. Right, so Vern Henderson and I sort of had this story in mind when we wrote our JEP paper, right? And we were looking for African cities to be a lot more dangerous than the countryside. We were looking for that urban mortality premium that we saw in the US in the late 19th and early 20th century. And we had trouble finding it, right? So the African cities were not obviously more dangerous than rural regions. Children of uneducated parents were more likely to get diarrheal disease in cities in the countryside, but not so for educated parents. Women were less subject to domestic violence in cities in the countryside. People were heavier in the city than the country. It looked like a wash, right? So without the sort of scourge of cholera and typhoid, why aren't African cities, if this story is right, why aren't African cities growing faster than they are, right? So it's where cities are growing fastest in the world, but like, what is the thing that is holding them back from growing even faster? Could it be public health, right? Okay, so what do we know about water and sewer interventions in public health, right? So hopefully I've convinced you that sort of public health is important enough that we should be thinking about it as an important determinant of the size and organization of cities. All right. So what do we know about water and sewer interventions in particular in public health, right? So there have been a lot of economic historians working on this, right? So a lot of economic history papers on this, right? So Allison and Golden do an event study where they ask what happens to infant mortality into municipalities in the Boston watershed between 1880 and 1920 when water and sewer mains jointly arrive. All right, so what happens to infant mortality to a town near Boston when water and sewer mains come to town, right? And what they found was a 26% decrease in infant mortality, right? So if you remember the figure I showed you before, right, this was a time when infant mortality was 1 in 6, 1 in 7, right? So they're going to knock that down by a quarter by putting in water and sewer mains. Okay. Right? So this other paper, Anderson et al., right, does something actually quite similar, right? They have annual data from 25 US cities between 1900 and 1940, not quite the same time period, right? And they're going to do an event study where they have a bunch of different treatments, right? Was there a municipal project to manage sewer outflows? Okay. Did the city start filtering its water, right? Did the city start protecting its water supplies, right? And what they find is that managing sewer outflows has no effect on infant mortality. Water filtration gave us an 11% decline, right? And that the joint effect of all their water quality related interventions was a 4% decline in infant mortality, right? So they're finding a substantial effect also, but it's almost order of magnitude different than Allison and Golden. Okay. Ferry and Truskin, right, do an event study around the way that Chicago had two main mechanisms by which it improved its municipal water supply. One was to reverse the Chicago Canal so that all of reverse the Chicago River so that all of the city's sewage stopped flowing into the lake where the municipal water supply came from. They sort of reduced that flow and eventually reversed it. The second was to move the municipal water intakes further and further out into the lake, right? And so they went from 2 miles offshore to 4 miles offshore, from a mile offshore to 2 miles offshore to 4 miles offshore. And they're going to do an event study around the movement of the water intakes further from shore. All right. And what that analysis leads them to conclude is that improved water quality reduced the crude death rate, so the number of deaths per year per thousand of population, pretty dramatically over about the same time period that Allison and Golden study. Right? A paper from Paris explicitly addresses sewering, and they find that adding sewers, completely providing sewer service to every house in the neighborhood that was previously had no sewers, right, would have increased life expectancy at birth by 1 to 3 years, right? So I have thought about it a bit. I cannot figure out how to turn that into a percentage that I can compare with the other papers that I just told you, but that is an economically important effect, okay? Werner Truskin has a very nice book studying the rollout of water and sewer service in 7 or 8 southern cities and finds that sewers played an important role in narrowing the black and white life expectancy gap. And Beach is a survey of all these history papers. Okay. In addition to, so we have basically 2 literatures, one studying interventions in the late 19th and early 20th century, and one studying modern day developing world countries, right? The highlights of the development literature are a paper by Galliani, and I forget his co-author, which studies privatizing Argentina's water supply services, and they found that led to an 8% reduction in child mortality, all from a reduction in waterborne disease, okay? Falotra does something similar. Mexico rolled out, there's a typo in this bullet point, Mexico rolled out municipal water chlorinization in the late 20th century, right? And they were going to basically do an event study, what happens in municipalities to infant mortality in municipalities when the water treatment gets to them, and they find that it reduced childhood mortality from diarrheal disease by about half, right? So these are sort of consistent with the results that Allison and Gold, right? But the interventions are quite different, right? So these are improvements to the quality of the water that's coming out of your tap, right? Not the arrival of a water and sewer main. Okay, the Gomper-Rabindran paper is panel data from Brazil. Brazil keeps really good data about this stuff. For every sewer tract in the country for 20 years, they know about mortality and they know about whether there was sewer service, and they're just going to do an event study. They find that the arrival of piped water, but not sewers, has an important effect of infant mortality. Okay. Devoto looks at this experiment where you get a subsidy for piped drinking water, and what happens if you take up the subsidy. And what he finds is, in Morocco, what he finds is no effect on disease, but a big effect on the way you spend your time, right? So if you don't have water in your house, collecting water is a chore, right? And if you don't have to do that chore anymore, that affects your time a lot, but not whether you're sick or not. So finally, a paper by Ashraf and company, including Ed, find that more reliable. They're studying buildings in Lusaka. They're studying people who live in buildings in Lusaka and who are where the water supply is unreliable. It gets interrupted for various reasons. What they find is as the water supply is more reliable, girls spend more time in school and childhood disease falls. Okay, so basically the chore of collecting water stops falling on young girls. They go to school and everybody washes their hands and is healthier. Okay, so where does this leave us? Okay, so I think that interventions that improve municipal water quality have been pretty well studied. Okay, and right, so you want to the thing it took me a while to see reading these papers is you really have to pay attention to what the intervention is, right? Because the interventions are not actually quite the same. Improving water quality and putting piped water in a house is not going to be the same thing, right? And the different kinds of interventions around water and sewer, putting a sewer line to your house is not the same thing as putting a sewer main into the neighborhood, is not the same as moving a municipal sewer outflow downstream from water intake. Right, so specifically interventions that improve water quality seem to have been pretty well studied. They seem to generally have important health benefits in the developing world and in the 19th century US. And there's been studies of Europe and Japan. There is weird disagreement about effect sizes, or else these treatment effects are heterogeneous in a way that I don't see any pattern to. Right. So it looks like water quality is important, but we have a lot to learn on that. The provision of piped water and sewer access is less well studied, right? There's some evidence that this is important for health and also that it's very important for other aspects of life. Like if you don't have to carry water every day, that frees up a lot of time for other things. And you have better access to water. Okay. The interventions are diverse. I said this already. The interventions is diverse. So these numbers that I just showed you are the same. Like you can compare them on the basis of outcomes. It's hard to compare them on the basis of treatments, right? So if you are a mayor in a developing world city and you are looking for systematic evidence about particular interventions, you're going to have trouble. That's just not well organized. The literature is not well organized for that. Okay, now what about the thing I started with? What about water and sewer intervention, the way cities are organized? In sort of one of the tables at the end of their paper that the referees probably made them put in as a robustness test, right? Allison and Golden asked whether the arrival of water and sewer mains, the thing that had such a big effect on infant mortality, asked whether it has an effect on the demographic composition of municipalities. Okay, right? And they have a lot of municipal data. This was Boston in the late 1800s, so what mattered is whether you were Irish or German or Norwegian. And so all of that data was part of the census, and they can check. And what they find is nothing. All right. Which goes against sort of everything that I thought about way people sort in response to changes in amenities. I thought poor people whichever was the poorest demographic would be shifting into the worst places. These are sort of the census data. It's 10 years. It's long enough for that to happen. They're not finding any evidence for that, but their confidence intervals are pretty big, right? So they're finding zeros, but they are not super precisely estimated. Okay. In some of my work, right, with Mike Corey and Toru Kitagawa and Allison Schertzer, we looked at a policy experiment in Chicago, right, where on one side of the street they got sewers, and on the other side of the street they got them 3 or 5 years later, and looked at what that did to land values. And we found that it just about doubled land values, right? So so our estimate of the effect of the arrival of a sewer network explicitly, right, was that it about doubled land prices. All right, work in progress. Work in progress. We are looking at the effect of in 75 developing world cities. Right, we are looking at the effect of water and sewer access on density explicitly. right, and demographics, right, by comparing observably similar parcels or census tracts on opposite sides of a drainage basin divide, right? Which when you cross the basin divide, it gets harder to provide sewage. Watch for this. We are almost ready to let out a draft. And what we find is that if we were to increase the share of central city population that had sewer, that would affect density by as much as Baum Snow's estimates of a radial interstate highway. Right, so Baum Snow estimated what would happen, what estimated the effects of radial interstate roads on central city population density in the US in 1950 to 1990. What he found is you put in an interstate and density drops by 9%. Okay. What we're finding is that if you on average, if you add 3%, if you sewer an additional 3 of 100 households in a central city, right, you get the same bump to density. Okay, so that the thing that I said at the beginning looks like it's right. It looks like water and sewer infrastructure, like doing things that affect your taste for density, is as important or about as important as infrastructure that moves people in and out. Okay, so that is consistent with what we found with what I found with the Corey et al. Paper. Doubling of land prices has to go with a big increase in density. Okay, everything we know about the way people substitute away from land and towards capital for their housing when prices go up says you have to see a big increase in density. So it looks like there's a big effect on density. But we're having trouble finding an effect on sorting, which is a little bit peculiar. Okay, so that's the state of research. All right, that's the state of the evidence. All right. If you want to do a cost-benefit analysis of anything except improvements to water quality, I think that the literature is that I think that's just not possible, right? I think if you wanted to do a cost-benefit analysis on the effects of water quality, I think you might be able to do that, right? If you were careful, okay? Many of the studies that of the effects of in this literature are difference in difference designs, which are easy. It would be nice to have more quasi-experimental evidence. It would be nice to have more quasi-experimental evidence, and because many of you are development economists, even experimental evidence. Like if anybody can randomize the assignment of sewers to houses or sewers to neighborhoods, like talk to me. Let's go. And then our understanding of how this affects the urbanization process is really rudimentary, right? Like the models have all directed our attention to agglomeration economies and the role of transportation. Like, and this has just been under the radar, right? And I think that there is some evidence that the effects, I think like I'm convinced that the effects could be large, and hopefully we will have sort of better evidence for that shortly. But there's some conflicting evidence too. All right, like the fact that it doesn't affect demographics. All right, finally, if in fact sewers affect density the way I say they do, right, then the literature on public health outcomes understating the benefits, right, because it's going to affect a lot more people because they'll migrate in to take advantage of the better services. All right, as far as I know, we know nothing systematic about the costs, right? If you want to do cost-benefit analysis, we need to know that. I don't think we know anything about that. And we are a long way from being able to do the sorts of welfare analyses of competing interventions that we're starting to see for transit, like the stuff that on quantitative spatial models analysis of different transit infrastructure. Like we just don't have the foundation to do that yet. So it'd be great if some of you guys wanted to work on that. And that's all I got. I'm 30 seconds over. I'm going to give it to Kelsey.
Thanks so much, Brad. Let's see if you want to take your slide. Okay, perfect. Okay, great. So I'm going to pick up off of that sort of really important and motivating motivation and talk a little bit about what I see as some of the core challenges. I'm going to take this in a little bit of a different direction. But I think what you've really seen so far, both from Matt and from you know, some of the other lectures, I believe, is that the effective delivery of urban services that are reliable, high quality, and also affordable, importantly, is a really core feature of what makes cities attractive. And so we see in a lot of settings, as Matt was motivating, that service delivery actually hits none of these bold font criteria. And Matt was, I think, describing how important this is with a focus on sanitation and the impacts that it potentially has on urbanization. What I want to talk about a little bit more in detail is why it's hard. So why it's difficult for urban governments, municipal governments, to provide these services in ways that are reliable, high quality, and affordable. I'm going to focus a bit more on water, in part because, as Matt was saying, there's just a lot less evidence on sanitation. So the concerns that I want to spend a little bit of time talking about are, on the one hand, really thinking about just the efficiency problem. So just the basic, it's sort of a local public finance problem in a lot of ways. How do you provide these services in a way that allows you to recover costs and function as as an urban government? But at the same time, balancing these other concerns, which are related to kind of equity or affordability. If you're serving a heterogeneous population where some households are very poor, other households are perhaps a bit richer, how do you balance the needs of this population such that you have kind of a thriving population? You mitigate concerns about the spread of disease and other issues like that. And then finally, if we have time, I'm going to talk a little bit about kind of some of the growing challenges around uncertainty, and in particular, when we think about water supply, the kind of shocks that may be increasing with climate change around droughts, around urban water scarcity, are kind of particular concern. And so if these challenges weren't enough for the government or the service provider, climate change is just going to make it that much more difficult. And so I'll spend some time talking about what we know in the literature about these first two bullet points, and then seeing on how we go. And if we don't get to it, the slides are posted, to use this case study from drought in Cape Town, South Africa, to talk a little bit about the importance of uncertainty for sort of increasing these challenges. So just to motivate in a slightly different direction, to think about kind of the scope of the problem around urban water availability. So estimates suggest that there are about 1 billion people who are facing urban water scarcity currently. This is a number that's growing quite rapidly, both because of urbanization, because of population growth, on the one hand, increasing demand, but on the other hand, as I mentioned, lower supply because of climate change, increased variability, and so on. And this is fundamentally kind of an urban problem that the slide is motivating, that that municipal utilities are often the ones responsible for providing these services. So to think about the model that's typically used for service delivery in urban settings, it's a what we might call a natural monopoly. So basically what we should think about is that households really have no other choice other than to buy, again, using the case of water, but sanitation is provided in a very similar way. And in some settings, electricity is provided in a similar way. Households have no choice, households and businesses have no choice but to buy those services from a single seller. And so that seller, often a utility, often a local government, has kind of monopoly power and has a lot of flexibility in how to set prices, how to recover costs associated with providing those services. And this is really what I want to talk about: is how do you design a system as a local monopoly such that you can cover what are often very high fixed costs relative to variable costs. And so what I mean by that is that the cost of setting up the sewer system that Matt was describing, the piped water supply system, that these are costs that this utility or this local government is taking on that don't depend on necessarily how much water people are using, how many times people are flushing their toilets. These are sort of costs that are associated with infrastructure. They're long-run investments, and covering those costs is an important part of this kind of service delivery model. What typically economists would think then you sort of should do in terms of setting the tariffs and setting the prices that people are paying is have households or businesses pay a two-part tariff. So both a fixed portion, per month, every month, you're paying a service charge of some kind that goes toward those fixed costs. And then in addition to that, you're paying something about the marginal cost to cover the marginal cost of the actual water that you're using or the sewer services that you're using. In practice, we don't see a whole lot of that. So what we see a lot of instead is that these kind of volumetric prices, meaning I'm going to charge you per unit of water that you're consuming, that these are set really high because they're trying to cover both the fixed costs of providing the service and the variable costs and the costs that vary with the amount that's actually being used. That's sometimes the case. What is often also the case is that these fixed costs are just not covered. And so we'll talk a little bit about that because that has implications both for what Matt was describing, which is the extension of services to more households, sort of the growing need for pipes and other types of infrastructure, or alternatively, for systems that were installed at some point in the past, not covering the fixed cost means often that service quality declines over time. As that infrastructure erodes, it undermines investment in maintenance and quality improvements. So some of the challenges that I want to spend a little bit of time talking about are challenges around recovering bills. So weak enforcement problems, the fact that bills themselves or prices may be distorted for political economy reasons, the role of subsidies or other types of price distortions. And then I'm not going to spend much time on it, but in the background, you should think about this challenge of expanding access. So population's growing, there's an unserved population. All of these first 3 points are needed in order to be able to serve that population. Okay, so starting with the first two, there's this nice term that's used by Spink in a 2022 paper of this idea of utilities as creditors. So the idea that in a setting where bill enforcement, so you're consuming some services, I'm the utility, the municipal government, I'm sending you a bill, but if you don't pay that bill, not a whole lot happens to you. This is pretty common. And in that setting, this is really kind of a transfer from the utility to the customer. Customers are given sort of cheap credit and can pay off these bills at some point in the future, should it become interesting to them. But this is a transfer that creates externalities on other users of the service. And so when one individual is not paying their bill, what this means is that everybody else's prices go up in order to cover that shortfall in cost recovery is one option. Or the other option is that the quality of the service declines because, again, of this incomplete revenue recovery. So this depends a little bit on how the utility responds to it. So one question we might ask is why do we see a lot of non-payment of bills in urban settings? Is this due to weak enforcement? Is this due to something like low tax morale? I'll come back to affordability in just a minute. It also may be that some part of the population just can't afford to pay these bills. There are a couple of papers, there's not a whole lot of evidence on this, but there are a couple of papers that look at improvements in enforcement and try to understand the impacts of that. So this Spink paper that I referenced before looks at improvements in enforcement capacity in urban Zambia. This Colville et al. Paper randomizes both engagement with the utility, so trying to do this kind of boost of morale, or do you feel like you should pay? Is there some kind of obligation to pay? But also enforcement through disconnections in Nairobi. They find no effect of increased engagement. So this kind of idea that you don't pay because you don't like the utility, you don't trust them, other things like that. They're trying to address that. They don't see a whole lot of evidence there. But on the other hand, the threat of disconnection has a big impact on payment probability. So they see a tripling of short-run payment of bills and an increase in medium-term bill payment by about 50%. The Spink paper goes a step further and tries to break this down. So we might worry a little bit about whether tighter enforcement is regressive, whether the people you're disconnecting are the poorest people, the ones who really can't afford to pay. So she, in this urban Zambia setting, breaks down the response or kind of the outcomes by whether households are a proxy for kind of richer or poorer. And what she finds is that the lower income, the poorer households in this setting are more likely to be disconnected when enforcement capacity goes up. They're less likely to respond by paying off their bills. Whereas on the other hand, the richer households, if they do get disconnected, they reconnect rather quickly, and they're more likely to respond to this increase in enforcement by actually paying off their bills. This is, suggestive evidence that there is some regressivity in tightening enforcement. But again, remember that there are these externalities from non-bill payment. And so we'll come back in a second to thinking about kind of redistribution. But alternatively, maybe this suggests some kind of potential role for targeting. So this is kind of consistent with concerns about why is it that people are not paying their bills. Maybe there's sort of a weak state capacity type of a problem that increasing enforcement can actually lead to more complete cost recovery. And that, of course, again, has these kind of positive feedbacks in terms of service quality and in terms of tariffs for everyone. It also may be that another thing that's kind of undermining cost recovery is political influence. Now, I don't know of much evidence on this in kind of the water and sanitation space. I saw somebody asked about this in the chat. There's some really nice growing evidence on this in energy supply, which has sort of similar features for cost recovery concerns and so on. So public utilities, particularly those that are controlled by, that are partly state-owned or fully state-owned, may be susceptible to political influence. There's a recent paper by Mahadevan that shows that in India, following a close election, there's some clear signs of political favoritism. There's sort of a quid pro quo kind of a thing going on where winning districts who aligned with the winner in this close election. The idea of a close election regression discontinuity design, if you're not familiar with it, is the idea that it's sort of as good as random. These were districts that kind of could have gone, or this was an election that could have gone either way. And so the fact that a district was on the winning side is sort of arbitrary. So we can compare in these cases winning districts to districts aligned with the winning party to districts aligned with the losing party. In this setting, the build power, the amount that those who are aligned with the winning party are being asked to pay through their electricity bills is actually lower. And so you can see that on the left graph here. What that's showing is that the build consumption for these households is actually lower if their party aligned with the winning, if their votes aligned with the winning party. But when she looks at an alternative measure in the form of night lights, it looks the opposite. So she sees evidence that in fact they're consuming more power, not less power, when they're aligned with the winning party. There's a bunch of other really cool evidence that kind of suggests that there's some cooking of the books going on in this paper, but we might expect to see this also in other types of urban services and bills that are being sent to people for water, for sewage, for other things like that. And why does this matter? Well, this matters because if people are not being billed accurately, because of some kind of political economy type of a reason, that it's going to really undermine cost recovery. And in this case, if the utility is serving both winning and losing districts, what they're going to have to do is either increase tariffs across the board to make up for the shortfall in the winning districts, or just lower their investment. So incomplete cost recovery, and this is a setting where power supply is quite poor, and so the implications of that may be pretty negative. Okay, so this is to kind of set the stage on why it's important to think about the cost recovery challenges. Now I want to spend a few minutes talking about kind of the affordability challenge. So this really goes hand in hand. Their feedback's kind of all along the way. As cost recovery declines, then maybe tariffs are going up. There's an old literature in public utilities that describes kind of this idea of a death spiral of eventually you're just getting a lot of kind of failure to recover costs. You keep having to increase tariffs, and eventually your pricing model really unravels. In low and middle income countries, this concern about affordability is really important because, one, there are many households who don't even have access, as Matt was motivating. There are many households who don't have access to sanitation services, to clean and high quality water supply. And these issues that we've been talking about around non-payment, I haven't talked about theft, but that's a particular form of non-payment, political interference, but also pricing distortion, all create these kind of externalities across users. So perhaps users who are not connected currently are going to be less likely to connect if prices have to go up to cover the fact that some people are not paying their bills. They may be less likely to connect if water supply is intermittent. So Matt referenced work in Lusaka, Zambia, that looks at interrupted water supply. This is an increasingly important problem where water's flowing in Mexico City a couple hours of the day, for example, in Johannesburg during the last summer for a couple hours of the day. So this kind of quality in addition to cost is potentially very important. So the failure to connect to the water supply, the non-payment of bills, the alternative, of course, is that some of this is driven by just prices that are unaffordable to some kind of inability to pay. And there are numerous justifications for subsidizing these types of services, particularly for low-income households. A common solution when we see incomplete cost recovery or when we see what looks like an inability to pay is to introduce subsidies. Sometimes these subsidies are targeted so that they're trying to reach particular parts of the population, but oftentimes they're subsidies that are just propping up a utility company or a municipal service delivery supplier. These are really common. I also went to the World Bank to see some kind of cross-cutting evidence. I don't have a nice figure, but I have a useful table. This is a little bit out of date. I don't know of a nice resource that updates this kind of broad cross-cutting evidence. But the key things to see here is when you look at untargeted subsidies, and basically what this means is like incomplete cost recovery. When costs are not being fully recovered, there's an implicit subsidy in place. That 69% of utilities in this global report were implicitly subsidizing water. So they're not operating on a kind of fiscally sustainable model such that they can't even cover their current costs, much less the investments needed to increase access, to increase quality of infrastructure. Then if we look at explicit subsidies, and I'll talk a little bit more about this in just a minute, increasing block tariffs are used by 80% of utilities. What this is doing, this is a targeting of subsidies in some sense. What is an increasing block tariff? This is a tariff structure where it's particularly common in water and electricity, where the first unit, the first liters of water that you're using or kilowatt hours of electricity that you're using, they're subsidized. And then as you increase your water or electricity use, the marginal price is going up. What this type of an increasing block tariff does in terms of targeting is it targets based on your quantity of use. So if you're a low user, your average price per unit will be lower. If you're a high user, your average price per unit will be higher. And the kind of motivation for the really prevalent use of increasing block tariffs is the idea that income is correlated with use. And so if lower income consumers tend to be lower consumers as well, this has this kind of byproduct of also targeting based on income. I'll talk about a little bit what we know about the effectiveness of this type of targeting. There's a really nice paper by Sean McRae that talks about some of the kind of detrimental impacts of subsidies. So what he shows is that pricing below cost can undermine investment in quality. This is also an application to electricity, but I think the analogy goes through really nicely with urban water. So this is a setting in urban Colombia where subsidies are being targeted by neighborhood. So in this case, neighborhood is used as the proxy for income. And what he finds is that people demand less electricity if the quality of that electricity is poor, meaning there are outages, meaning there are voltage fluctuations in water. This would mean that pressure is going up and down. This would mean that there are some hours of the day when there's just no water supply. That bill payment also depends on the quality of the supply. So when the supply is poor quality, people are just less willing to pay their bills. The utility decides whether to upgrade infrastructure based on the returns that they're going to get, net of whatever subsidies are being provided by the government. And what this does is this means that the amount that households are paying, both because of incomplete bill payment, but also because their prices are subsidized, means that the utility is going to have less of an incentive to invest in infrastructure improvements in settings where these subsidies are in place. This leads to this kind of what he calls this subsidy trap, this idea that that you're going to get this kind of cycle of lower service quality, less bill payment and less revenue, therefore fewer investments, and therefore for less service quality. This is something that, to my knowledge, has not been studied as well in for example, water or sewer, but the analogy is likely to go through. So actually, in the interest of time, I'm going to skip over this slide. I think we've talked a little bit about it, and talk just for a few minutes before spending the last 5 or 6 minutes on the case study about targeted subsidies. And what do we know about targeted subsidies? As I showed you on the World Bank table, these are really ubiquitous, and so a really common way that local governments around the world do social service support is these in-kind transfers through water tariffs, through sanitation tariffs, through electricity tariffs. Now, the question is, do things like increasing block tariffs effectively reach low-income households? What are the alternative ways of reaching low-income households, if that is the desired goal, of course? So a lifeline tariff is something that, I think in some of the settings that the students here are coming from, this will be very familiar to you. This is just a really extreme version of an increasing block tariff where the first block is free. And this is really common in a lot of different settings. I described to you already the way that this is intended to kind of target and redistribute. There's a bit of work on the distributional impacts of this, but I think there's really a lot more work to be done. So Andrea Szabo has a nice paper where she studies this free basic water allocation in urban South Africa. And she finds actually that because in this setting it's targeted just based on the volume of water you're consuming, not based on other proxies for income, this works pretty well in the sense that almost everybody's consuming more than this free block, such that this is just a transfer. It's not really distortionary because it's not really changing the marginal cost of water that people are paying. So it has a relatively small effect on water use. But on the other hand, she doesn't find that it's very redistributive because everybody's getting it. And so everybody's getting this kind of transfer from the utility in this in-kind way, rather than really boosting the poor. And so you can look at the paper if you're interested in kind of what she takes away as the policy implications. But this finding in some ways is not unique. So Severin Bornstein, my colleague, has work in electricity, mostly looking at the US, that also shows that these increasing block tariffs are really not achieving a lot of the kind of distributional objectives because their usage is just not that correlated with income. If low-income households tend to be bigger, if people are living in compounds, for example, then it may be that their usage is high, even if they really are kind of in need of these types of subsidies. Now, of course, these subsidies kind of turn around and go back to this incomplete cost recovery problem that I started off with, and so these things are not entirely separable at all. The more you're subsidizing the first block, the more you have to increase prices at the top of the tariff schedule, or introduce fixed charges, which is often, as I started off this slide deck with, what most economists would recommend as kind of the efficient tariff design in these settings, even though we don't see it all that much. Okay, so I want to spend my last 5 minutes just plugging a kind of case study that brings together a lot of these issues, and that also introduces sort of the growing concern that climate change may have on this service delivery model. So this is looking at, if you think about kind of the poster child for near urban service collapse in the face of climate change in the last century or so, it might be Cape Town, South Africa. The term day zero has now been kind of co-opted, and not co-opted, but adopted by lots of urban settings. So again, Mexico City over this last summer was a prominent one, where the media is now using this phrase day zero to refer to the idea that water supply gets so dire that it just shuts off altogether. And this was a crisis in a city where otherwise urban service supply is actually pretty high quality, pretty good. An extreme drought led them to really have to re-interrogate their service delivery model. So the question that we're trying to understand is these long-term consequences of dramatically responding to a really dramatic crisis. And what happens during this crisis when water supply collapses, a utility has a really hard time adjusting to this in the short run. This is something that's actually a little bit unique, I think, to water, in the sense that the supply is really inelastic in the short term. And so there's not that much you can do in the face of a drought if suddenly there just is not water to supply to households and businesses. Now, consumers are going to respond to whatever the utility does in this first place. And what's going to be really important in this story is the role of substitute. So I started off by describing the idea that this whole service delivery model often rests on the monopoly power that the utility has. If households have substitutes, in this case, it's going to be groundwater, then this really undermines the ability to charge prices that recover costs potentially. So this is a setting where the water supply is really vulnerable to climate shocks. So dams supply a large share of pretty much all of Cape Town's water. At the peak of the crisis, the dams looked like this. And so at some point, you're just pumping silt. There's no more water to pump. This is what day zero would look like. And this was, as I mentioned, really kind of all over the media. It didn't happen. And so there was kind of this brush with the idea that you were going to shut off piped water supply. How did the city reduce demand? How did they avoid this kind of total collapse? So what they did is, during the crisis, they needed to reduce demand so that they wouldn't run out of water. They did that in this setting by increasing prices really dramatically by about 1,000%. So extremely dramatic price increases. In other settings, what do? They ration water. The implications are actually pretty similar if you think about kind of the theory of how households are going to respond. So a few things happen. One, the dispersion across incomes in the amount of water that they're using really collapses. And this is driven in part by substitution by wealthier households toward groundwater, towards substitutes. So this could be, we measure groundwater in this paper, but other things that have a fixed cost that allow wealthier households to reduce their water use, like gray water systems, like water efficient appliances, are going to have similar properties. This contracts the revenue base because these households are going to continue to consume the substitute even when the drought is over. So this contracts the revenue base, and it redistributes some of the fixed costs away from the richer households toward the poorer households. I'm not going to have time to go through all of this. This is the tariff increases. A couple of really striking figures to kind of leave you with. One, you can see the lighter lines here are the richest households in Cape Town. The darker lines here are the poorer households in Cape Town. This is proxied by property values prior to the drought, which starts kind of late 2015 and 2016. Prior to the drought, the richest households are using a lot more water. Their water use is very seasonal. at the peak of the drought, you can see this gradient completely collapses and even reverses, where the richest households are actually using less public water, less municipal water than the poorest households. And what's really striking is following the end of the drought, after you get out of this gray bar, this contraction really persists. So what we find is some evidence that at least some of this contraction is driven by the adoption of substitutes, by rich households paying the fixed cost to drill wells and access groundwater. This gives them a way of exiting the grid, exiting this municipal service supply. And what that's going to do is that's going to mean that when this drought, this crisis is over, the utility needs to collect revenue again. They need to cover their costs again. But these rich households, you saw that contraction persisting, they're not increasing their consumption as much. Now, what the city did, which makes all of the economists cheer, is they introduced fixed charges. And they did even better than that. They introduced fixed charges that were graduated based on income, so that the richer households were actually paying a higher fixed charge and contributing more to this fixed cost base that the utility really needs to be able to operate. So you can look at the paper if you want to see more of the details on this, but I think that this is kind of a general story of utilities have a hard enough time recovering costs in a setting where the supply is not really variable. You add climate change to that, this really variable supply, and this is going to create new challenges that we haven't necessarily seen in the past. And it's also kind of another way of thinking about the regressivity of climate change. So I'm going to leave you with a few of these open questions that I think in this area, thinking about tariff design problems. This is a really different set of questions than the ones that Matt had put up. This is more about how to manage the challenge of service delivery that is reliable, high quality, and equitable in urban settings. So thank you so much, and look forward to questions and comments.
Wonderful. Very much, Matt and Kelsey. I enjoyed that very much, of course. I particularly like, it's always good to leave some PhD students with some open-ended research questions to pursue, which I think both of you did wonderfully there. I have some other thoughts, but no one's here to listen to me, so I will move straight to the Q&A part of this. Now, as promised at the beginning, those who kind of wanted to participate live, you do get first dibs on asking any questions. So those of you who Greg kind of ushered in, if you do have a particular question, please raise your hand and I'll come to you shortly. I also want to say, for those that were most highest voted, Tina's, Jack, and Assad's questions, if you want to ask those live, you can raise your hand as well, and Greg will bring you into this kind of special room here. If not, I'll ask them for you. So I'll just give you a moment to raise your hand. But is there anyone in the existing room that has a question so far who we've brought in? James, Francis, Abdul Karim. While we start, I'll begin with the top voted one, as I did promise. Oh wait, do we have Jack? Oh, Jack, you're here. Okay, wonderful, Jack. I'll let you, Greg, if you can unmute, or Jack, you can unmute yourself to ask a question. That'd be wonderful, since you were one of the top voted ones.
Yeah, hi everyone. Thanks so much. Those were really interesting. I've lost where I've written my question, but I think I remember what it was. It was basically sort of thinking about your presentation, looking back, at the history of sanitation in cities and how they sort of were initially, these systems were initially put in place sort of in currently rich cities, sort of at the turn of the 19th, 20th century. I'm just trying to think about sort of opportunities for developing country cities now, to kind of looking at the last maybe a few decades of technological progress, where there's opportunities to kind of leapfrog, and jump ahead a little bit in terms of some of the lessons that were learned in, currently rich cities. So I'm just trying to think about what kind of progress has been made in sort of water and sanitation technologies that current developing country cities might be able to use, and yeah, or is it kind of just looking pretty much the same as it always has? Thanks.
I think I can take that. So you are not the first person to think about that, and sort of engineers have been beavering away on this for a long time. And there are lots of different technologies. I don't know a lot about what's implemented. My sense is that Brazil has been particularly effective at implementing sewers inexpensively, right? If you want to find out about this, there are a couple old books by a guy named Mara, M-A-R-A, right, where he describes all these technologies, right? Which is, I think he was a consultant. He was a consulting engineer for the World Bank, I think, for a long time, right? So it's MARA, something like low cost sewerage, right? Or if you really want to sort of nerd out on this thing, which I did, the big civil engineering reference for modern countries is there's a Bible. I'll go grab it. Hang on. All right. It would have been a really cool trick if I could have just disappeared and come back with it in my hand. But if you send me an email, I will send you the name of that. It's the Bible for civil engineering of water systems in developed countries. So the answer is yes. All right. The answer is yes. There's clearly a lot of different technology out there, and it is not clear the extent to which it is being implemented effectively. Like, I have no idea if Colombia is operating at the production possibility frontier. My sense is Brazil is, but I can't tell you. I don't have very much detail on that.
Nice, thank you, Matt. Yeah, you maybe need to get a better referencing system on your personal library in place,
Yeah.
or by color code. That always works beautifully. Francis, I'll come to you in a moment. So I see you had your hand up, but I want to ask this question that Assad has put in because it's come up in a few different variations as well. Maybe Kelsey, you can speak to this. And it was, can you tell me a little bit about financing of water? Oh, it's just disappeared from my view. Can you tell me a little bit about financing of water and sanitation services, especially in developing countries with severe fiscal constraints? And then there's this add-on, which I've seen quite a few in the Q&A, which is like the extent of privatization. You know, does it add additional burden on financially struggling households? I think one of the papers you touched upon, but a little bit more would be welcome if possible.
Great. No, those are really important questions, and I think this is sort of the crux of what I was trying to get at, is that there is this tension between the fact that the cost may be high, and in particular, this is a setting where the capital costs are really high of setting up a system in the first place. Financing that is difficult. To finance it from users may mean that there are really high connection charges. Then if you get fewer people connecting, you can't cover the cost of the water treatment plant or other things that don't actually depend on the number of users. So this is, I think this is kind of a central challenge of, one, getting started, but then continuing to maintain these fixed costs, continuing to invest in service quality. One option that we see, for example, is the federal or state government kicking in subsidies for those kind of capital investments. They may be covered through other types of property taxes. Other types of taxation is a way that that also may be done when the utility is fiscally independent and has to cover these costs itself. Borrowing is often the alternative if it's a fiscally constrained utility who doesn't have access to borrowing. That, of course, may be off the table. So all of these things create these kind of big public finance types of challenges. Privatization is a solution that comes up in various settings. The cost structure doesn't fundamentally change with privatization. Access to things like borrowing may change a lot with privatization. The willingness to offer subsidies may, of course, also change with privatization, but perhaps with benefits for efficiency. So the Galliani paper that Matt put up in his slides and referenced in his slides is actually a study of privatization. It's in Argentina when the pipe water supply was privatized. They see improvements in water quality that lead to these reductions in infant mortality. So they find some quite positive effects in the relatively short run. They have a longer run follow-up paper that maybe if Matt knows it better than I do, he can say a little bit more. But my understanding is that some of the relatively short run benefits that they found in their JBE paper don't persist in the kind of medium to long run. And I don't know what, I don't know exactly how they explain it, but I don't know of other really systematic studies of long run impacts of privatization, which seems like, a big part of the question.
Sorry, don't know it.
Yep. Okay. That's good. Anyway, students can do their research and go track it down.
Thanks for putting me on the spot. Oh,
You have opportunities.
Nice. Thank you, Kelsey. Francis, I'm gonna hand over to you, and then I think Greg, my wonderful assistant, is going to contact some people in the chat who have had some questions as well. But Francis, the floor is yours, and yes, as short and concise as possible, if you may.
Yeah, thank you very much. I'm Francis Mwangi from Hazard University, also doing my PhD in applied economics. I'm from Kenya. My question is on the issue of stakeholder awareness and engagement, because one of the issues on sanitation in Kenya is lack of stakeholder engagement, where you find the downstream water where it is spread, it is shared. Some don't have water, and that leads to a lot of effect, because some of the people try to create their own channel to draw, for example, water. So I think there is a key gap in terms of stakeholder awareness and also involvement of the key. And I don't know how, like in US, it's done to ensure that there is that buy-in. Thank you.
This sounds like a question about water rights law to me. And the US is probably not a model for that. But this sounds like if I had that question, I would start reading Eleanor Ostrom's book about the management of common pool resources. That'd be the place I would start.
I think there's an additional piece, maybe, Francis, that I can respond to in your question. That's also, I noticed, has come up in the chat questions quite a bit about informality, right? When you have people who are, some people who are connected to a formal water supply, and then others who are adjacent to that formal water supply, but they themselves do not have access. And this, I think this raises a few issues. So depending on the setting, you can see things like what you're describing of trying to divert water away from the formal pipe system, whether that's through tapping in, as Matt was describing, the core of how piped water works is through maintaining water pressure. And so as soon as you're getting people trying to tap into the water mains, for example, this has really negative effects throughout the whole system. But then, how do you kind of manage this, and the kind of exclusion through really high connection charges has been one issue that has received at least some attention. I know of more work in electricity of thinking about the role of fixed charges for connections, but that can be one reason that households that have access, in the sense that they're near the piped water system but they themselves are not connected, high fixed charges may be a big part of that. Now, there's some evidence that the way that fixed charges are used, and this is a paper by Sean McRae, which I had cited another paper of his, and Musa Blempo and a couple of others. One of the ways that fixed charges are used, at least by electric utilities, is sort of rationing, is trying to keep customers that they don't think are going to pay their bills at some point in the future, keeping them from connecting in the first place. A different rationale for fixed charges, and one that we think is kind of more efficient potentially, is to cover the actual cost of the utility. So to the extent that those fixed charges are kind of cost reflective, we may think that they make sense, but they may be regressive in the sense that the households that are credit constrained or cash on hand liquidity constrained are the ones who are going to have the hardest time covering some kind of a lump sum upfront connection costs. Ways of dealing with that, include potentially thinking again about targeted subsidies of some kind, targeted transfers, potentially credit specifically extended for connections or other things like that. But I don't know of literature that really evaluates those kinds of policies. And then I think what you were alluding to a little bit about kind of engagement is also just the idea of education, of making sure that people understand how prices are being set, understand what the kind of billing system looks like, that there's transparency, that these problems with kind of political distortion don't mean that trust is being completely eroded. They're kind of there's a long list of issues, and so this is a topic area where PhD students should have a long menu to choose from in terms of challenges to try to investigate. Thanks for the question.
Okay, we're drawing to a close, but I would like to ask one more if possible. I was trying to get them to potentially speak, but I don't think they have come through, but that's fine. I think this was interesting, it kind of speaks to a little bit I'll read it out. It's from Naila Tasneem. On water and sanitation having a direct bearing on health, nutrition, and disease prevention, but it's a little bit more this political economy. Why do they not have an incentive to overcome these challenges by providing the improved sanitation and sewerage? And I suppose in that is a bit of this, like, how are we measuring these both direct benefits and indirect benefits, and at the kind of different spatial scales, I suppose, in my mind, right? Just a brief thought from one or both of you.
So the question is, like, why are there not more sewers and better water supply in the world?
Particularly because they have this direct bearing on health, nutrition, and disease prevention.
So like this is like, let me paraphrase. There is some valuable public good which is underprovided, right? Like, so that is a classic problem. We understand why public goods are underprovided. Right. So what we are doing is documenting that what the literature is doing is documenting that this public good is important, and providing a basis for arriving at the conclusion that it's underprovided. Like, that's not something that strictly we can conclude yet. And the literature has been studying public goods provision since Marshall, right? And what Kelsey is doing is sort of trying to do describing sort of the economic engineering around solving that problem, but like the principles of that problem have been laid out, since Marshall.
Yeah. Nice. Good. No, it's true indeed. Okay, I'm going to probably bring it to a close now, unless there's any other burning questions. I don't see any hands, because I think it's always good to finish these things on time. So I'll close the discussion. I'd like to thank again, Matt and Kelsey, our speakers, and also to you, our audience, for your wonderful questions. I was trying to find a kind of an economics joke related to service delivery before this that everyone has to indulge me because I'm chair. And it said, why do the economists advocate for smart water meters in the connected city? And the answer was, because efficient service delivery means you can finally measure demand without tapping out the supply. And I like a pun, and I thought I would end with a pun. So there we are. Thank you, everyone, for joining. The slides and this recording will be available online, as well as all the reading lists and all the readings that both Kelsey and Matt have spoken to. So I think there's a lot more in there to get to grips in, and indeed those wonderful research questions that they indicated at the end. We very much look forward to seeing you next week as well, where we will have Joanna Monterio and Augustin Bergeron, and they're going to be speaking on kind of prime and state capacity, or as we're calling it, making and breaking the city. So thank you very much, and hope to see you all then.
Thanks, everybody.
Farewell.
Thanks a lot. Bye.